So I'm going to do a recording here to show you some perspective drawing for I'm going to call it a pencil holder, could be a screwdriver holder. This would be suitable for a little design project for GCSE Design and Technology, or for BTEC Engineering or WJEC Engineering. And it's really about graphical communication with a little bit of precision. Quite often you're going to be asked to do a redesign task of an object, so you'll be shown a product and you then have to do a redesign of it. So I'm taking kind of an idea from a couple of things that I've looked at, and I'm going to show you two-point perspective. Now, two-point perspective is not an engineering drawing process, but it will lead us into an orthographic drawing, possibly looking at how isometric and oblique and perspective work together. I think this is a good exercise for design communication. So we're going to end up, as always, I do a little sketch of what I'm going to do first of all. This is not a great design for a screwdriver holder, but it's an exercise in perspective. I've given myself some key measurements. Now, I do measurements so that I can describe them to you. When you come to doing your own sketches, you can be much more free with it than I'm being. I'm being very prescriptive to make sure that you're successful, and obviously that slows the whole process down. So this process will take about 30 minutes. In reality, you could do this drawing, hopefully if you were sketching it a little bit, 2 or 3 minutes to do a rough outline sketch, maybe 10 minutes if you were doing a nice presentation sort of drawing of it. So although it's taking quite a long time in this video, the real process should be much quicker. So we're going to start off by positioning our two vanishing points, because this is two-point perspective. We're then going to draw a vertical line straight up the page, which gives us our front corner, and then I'll do a series of measurements from that. So I hope you can kind of follow along. Our first two measurements from these top corners are 4 centimeters, 40 millimeters. Remember, in engineering we would normally talk in millimeters. We're then going to measure across 125, and I'm just looking at this measurement here. This is one that I haven't looked at. That's 40. Okay, so we're going to come across 125 to do our vertical line, and then come up 40. Okay, so if you follow along with me, pausing as you go, hopefully this will all make sense. So top left and top right are vanishing points, often referred to as VP1 and VP2. Those are 4 centimeters down from the corners. Okay, 40 millimeters. I'll write that number on. You don't need to write the number on. Our vertical line at the middle is then going to come in at 125 mil. 12.5 centimeters. Now you can, if you want to be precise with this, you can choose to do that again on the top. But I think it's quite good practice as well if you get into the swing of putting your ruler and seeing if you can gauge 90 degrees up your page anyway. Okay. Now remember, when we do these perspective drawings or any orthographic drawing, construction lines are really important, so they should be as light as you can make them. Now I'm doing them slightly darker so that you can see them, but you should do them almost like they're semi-invisible, really, really light when you do this. Okay. So that gives us our first corner. Now we're going to do 40 millimeters up, and then from that a further 40 millimeters. You could choose, if you wanted to do 40 and 80. Okay, so it's 40 and 40. And then, if you think about any cuboid that we've drawn in perspective before, you're going to go from each of those 2 points to your vanishing points, so to VP1 and to VP2. And we're going to basically construct this as a cuboid. Now, when you're doing these yourselves, you might want to consider trying a different position for your vanishing point. I quite often draw with quite an extreme perspective. What I mean by that is my vanishing point is quite a lot higher than my drawing, because I like the appearance of that. But depending on what information you're trying to convey, to give across, you might decide to use a different position for your vanishing points. So you might want to look more straight on at an object, as though you're facing straight forward. You might even want to look straight up at it. So that very much depends on where your vanishing points are in relation to your object. But we're using VP1 and VP2 at 40. We've come across 125. We've come up 40. We've come up 40. We're now going to measure across the objects. Just checking my measurement there. From this front corner, we're going to go back along that lowest line, 5 centimeters. Okay, and we're going to draw a line vertically. So remember, we talk about parallel, where two lines never meet, they're at the same angle. Vertical and vertical. Okay, so that's going to be our back left-hand corner. And then let me just check my measurement again off this. We're going to come along the bottom right, 8 centimeters, 80 mil. Okay, and again, nice vertical line, try and keep it parallel with that. Check it. Okay, so that gives me my back edge, that's my front corner. We're not going to go over these yet because I'm actually going to do a slightly different construction on those. We now go from each of those to our vanishing point. So from the top of each of those two lines you've just drawn, you go to your opposing vanishing point. Can't go to that one because there's already a line there. You can't go to that one because there's already a line there. So you can only really go to your opposite vanishing point. Now, quite often we start by drawing a box, and it makes a great deal of sense. If you think about any object, it can either be very boxy, whether that's a plank of wood, a brick, a building block, a house. But within a block, you can then do what we call crating, where you take your object and you draw it within that overall volume of a rectangle or a cuboid. Okay, so a cuboid is a really, really good starting point for other bits of your drawing, which is why we often start this way. So this is a screwdriver holder or a pencil holder, so what I now need to do to it is to create something that makes it a little bit better for standing up, and I'm going to create some spaces for the pencils to go into. Okay, so our starting point, let's do a couple of little tabs coming off the side at the bottom, one sticking forward, one sticking back. So in my head, when I was coming up with this, I was thinking this is a sheet metal project, or potentially a piece of line bent acrylic. Maybe it's been laser cut. So if it was metal, that wouldn't be able to be laser cut necessarily. It would be probably plasma cut, or it would be pressed and punched. If it's acrylic, it would probably be laser cut, and then it would be line bent using heat. Anyway, look, we're going to come forward to show that front tab, and I've given it a measurement of 12 and the back one a measurement of 8. So I'm estimating a little bit here because I know that things that are further away are smaller. So I've taken 12 as my measurement here, and I'm going to take 8 because it's further away. I've taken a few off, probably a little too many if I'm honest, but I'm going to run with it anyway. So I need to have a little line coming forward. We call that projecting forward for where that 12 is going to be. So I'm still coming from VP1 along that bottom edge. Just run my construction line forward a little bit, and then I'm going to measure at this point 12, and at this point 8. You can see how important it is to have a nice sharp pencil for this, because otherwise your measurements can't be accurate at all. So from that one and that one, I'm now going to go, I can't go off to VP1 because there's already a line there, so I must be going off to VP2. Now here, the object itself is going to block it, so I only want to run as far as the next line. There it is. It would, in reality, go all the way off to VP2. So don't go making that up. It's got to go to VP2, but you stop it when you get to that line there. Now this one, because it's in front of the main object, we'll see all of it. So we'll take a construction line off to VP2, all the way. So how long is that going to be? We're going to use projection again, and we know that this changes shape. There's a bend here, so I'm going to use that point to project forward. And again, some of you might be going, oh, just join a line up there. It has to come from VP1, and we come down, we come through that corner, and we project out to there. And if you don't do that, your drawing will be wrong. And these are where you need to do your sort of quality checks on your own drawing. So we come forward, and that now gives us the back edge. Here's our front corner, here's our back corner. Okay, now I'm just going to leave it like that for a moment. without going into any thickness, but I am going to just darken in this front edge here. Remember, this is sheet metal, so I'm actually going to leave this line here because I think I'm going to plot through there in a minute, but I'm not going to do it yet. But that front corner we're going to keep, and I'm going to use that as a measurement. So my next question, I need a centre line, and what you'll notice is that I've drawn 3 square holes to suggest where the pencil or the screwdriver or whatever goes. Making a square hole is more complicated in a normal workshop than making a round hole, because obviously we're not drilling it. But in industry, you would, in a manufacturing environment, you would be able to punch out a nice square hole quite easily as part of the manufacturing process, maybe at the same time as you're doing your folds and bends. So that would be stamping out or punching out. So I'm going to stick with squares. Now, I need to know where the middle is. I want them to run down the middle of this. So the easiest way to do that, I could measure that line, but remember, in perspective, things get smaller as they get further away. So the best way of finding the middle is to use the trick of going from corner to corner. Right, now I don't need to go all the way across. I just need to estimate where that middle might be and draw a bit of a line. And then that corner to that corner, I don't even really need to draw a line, I just need to do a dot. I'll do a slightly bigger line so you can see it. So that goes from that corner to corner, gives that one from that corner to corner, gives us that one. All that achieves for us is the middle. So where those 2 lines cross, if I now go to VP1, that tells me where the middle is. Okay, so that line runs through there to there. Now I needed it to come down to this corner here and here, because I'm going to divide space again. Okay, here's our front side half, there's our back half. So what I'm going to do is to divide the front half by going from this corner and that corner to the middle, and that corner and that corner to the middle. Now I've actually got another line that I could potentially use. I'm going to draw it in. You could do it without this line, but it's quite useful for what we're doing anyway. Come all the way along. Okay, so that line there goes off to VP2. And what I'm going to do is I'm going to plot on either side of that line, front and back, to give us the width of our 3 holes. So to give us this width, I'm going to plot back. Okay, now again, I'm making up some measurements here to compensate for it being a little bit smaller. So I'm going to use my 1 centimetre there, but I'm not going to position the middle on that line. I'm actually going to measure back 4. I'm going to measure forward 6. So that is longer than that. Okay, I'm just going to double check that. Okay, and now from each of those 2 marks, I plot back to the vanishing point. Really lightly here, because there's quite a lot of lines are going to appear in here in a minute. So we'll plot back there. Let's call it the vanishing point. And we will plot back there. Okay. Now, corner to corner, it's going to find the middle, and we're going to use this point, we're going to use another point at the back and another point at the front. So if I just go corner to corner, hopefully what you'll notice, remember that's where that corner comes from, you'll notice that that crosses that middle line. There. Okay, so that was going from that corner to that corner, and that corner to that corner, gives us that middle line. Do the same thing again. So on the back, that line and that line and that line are all formed by going from corner to corner, and corner to corner. And you'll notice that they do stop on that middle line. Okay, so what we're going to do now is we're going to create a center line for our square holes. And remember, this is where I said there's lots of measurements and stuff going on, but in reality, if you just take a pause for a minute and we'll work on these lines in a second. So if you kind of want to just double check and watch that video again just to make sure you're in the right spot. But basically, each of those, we're now going to do a center line coming forward from that vanishing point through there. Okay, so although it looks complicated, we're actually just following the same process. One, two, three. So there's my 3 lines. Okay, now they run into these lines here. And this is where our next bit of measurement comes from. Here and here, here and here, here and here. Okay. Now, I'll put some numbers there just to give you a little bit of a starting point. Again, because things get further, as they get further away, get smaller. What I've done, I've fiddled around with these measurements a little bit. The first one is going to have a distance of 12. Second one a distance of 10. Third one a distance of 8. All right. Now, to keep it simple, we're going to measure on either side of our line. Again, in perspective, this side would probably be smaller than that side, but it doesn't really matter on the scale that we're working. So we're going to go on either side of the first line. We're going to go 6 and 6 to give us 12. Okay. Now to keep this simple, I'm going to draw that in as a square before I go any further, but I'm only going to draw between those 2 lines to try and keep the lines to a minimum. So from each of those points which were at 6, I'm going to go across to the next line. Okay, that was a 6, that was a 6. From that middle point, they are going to VP1, don't make them up, they go to VP1, and that gives me my first hole. I'm going to just darken that line in for a second, don't get confused. Okay, so the next one we said was going to be 10. So I position my ruler so I've got a 5 and 5. And then, so there's my 2 marks off that centre line. So we go back. VP1. You do need to be precise with this. If you miss your vanishing point, things will very quickly start to look like they're very wrong as an optical illusion. So don't cut corners with going to your vanishing points. Don't cut corners with sharp pencils. Okay, there's my second rectangle, and then my third one was going to be 8 in total. So I go 4 and 4. There's my 4. There's my 8. Hopefully you can see those. Make sure you position your ruler carefully when you put it down. So I'm still running off to VP1, although I'm only drawing my line here. Okay, and there's my third one. Okay. So quite a lot of measurement to get to that point, but we're kind of done now. The next thing that we're going to do is to give it a bit of a thickness. Okay, now I'm going to estimate this a little bit. If it was in a piece of aluminium, it would possibly be up to about 1.2 millimeters. If it was a piece of acrylic, it is likely to be 3 millimeters to get a shape like that, 3 millimeters thick. If it was a piece of steel, it's likely to be 0.8, so not quite a millimeter, 0.8 of a millimeter. But we're going to estimate it so that we've got visual communication here. So I'm going to just decide a thickness here. If you look, I've just plotted down a little bit, and I'm going to use that as a bit of a guide. I'm going to keep this line here about that thickness. going to just plot back to my vanishing point here from that. So remember, that was a bit of a guess how big that was. I'm going to plot back. And the reason that I've plotted backwards from that is I quite liked the thickness here, but I wanted to see what that thickness was there. Okay, so that's slightly smaller than that. I can now use that as a guide for this thickness, because it's at the same distance, so it's going to visually be the same thickness. I'm going to just plot. Look, I've actually just plotted a little bit lower there, and the reason for that is that we've also got this bottom bit to do. Okay, now if I look at that, it's starting to get quite thin at that point because we're far back. So just be careful you don't get too narrow, but visually that looks about right. About right to me there. I'm just taking account of the thickness of my pencil then. Okay. If I actually measure the thickness there, at that point I'm at about 1.5, and at that point I'm probably at about 2.5, 3. So it's beginning to perspectify itself. Right? Now, the reason I've kind of gone from there backwards, because I wasn't really sure how thick I want it to be there, but I can now plot it from here, from VP1, through that line there, plot forwards, and that gives me that thickness. I think I've actually got a bit thinner. It looks like I'm about that thin, that same size there, but I'm not going to worry about it too much. Okay, and now last thing I'm going to do, I'm going to plot a line parallel with that at about the same thickness as that and that. Okay. And then finally, not finally because I'm still going, from here I'm going off to VP2, and I'm going to stop it at that point in a minute. That'll be my back edge, but I'll add that in a second. Make sure I'm lined up. Off towards my vanishing point, and then do a little vertical line there. Okay, now I should have done that with a ruler probably. That's bad practice, so I'm just adding it in. And again, once I'm happy with it, if I've done a little bit of a check, I'm not totally happy, but it will do for us to now. Okay. You can see how important a construction line is. Because I'm drawing a little bit dark, this would be a real problem. How smudgy that gets trying to rub it out. If I'd drawn that nice and lightly in the first place, I wouldn't end up with a smudge. So I'm going to leave it there rather than rub it out. Right, so I've now got a thickness that I can use for here. And that's going to be from this point. If you want to be, you could get away making this up a little bit, but I'm going to do it from this line here to that vanishing point. I'm going to just do a little careful sketch. It's interesting. Inside each of those. Okay, so that's going to be part of my back edge. And then where that corner is here on each of them, I'm just going to come down vertically to join that line. Alright. I'm going to just darken that in again. Up to that line, because this is going to be definitely a keeper. So I'll darken it in so that you can maybe see it a little bit better. Okay, so that gives me my back edge, and remember that was based on that point there, that thickness. Now, if you sort of made it up a little bit, providing you've still gone to your vanishing point and you've got one thickness there, and you plot them all, it should still come out the same. Okay. Next bit, from your vanishing point, from that corner to that line. Now, you won't see a huge difference in perspective there, but again, if we're doing it accurately, you might as well do it properly off that now. So keep it on the vanishing point. Just check I'm about right. 1, It's so important to be precise with this, because if that moves there, your perspective is going to look out, and once your perspective looks out, then the whole thing can look a bit funny. Okay, so we've got a thickness at the front, we've got a thickness inside each of our squares. Now, the last bit that I'm going to do is going to be from this corner here off to the vanishing point. So from that corner to that vanishing point, but I'm going to stop it when I get to this surface here. See how that did run off to that point. You might have noticed me a minute ago, just doing a little check off this corner to see whether or not I'd see the back edge of it, and I think actually the back edge of it would be about there in this. I'll leave that as an optional extra. Alright, now again, if you were doing this for a project or for your exam component 3, if you're doing the BTEC engineering, or if you're doing component 1, I think it is in WJEC, it's about graphical communication and giving information. If you get your perspective slightly wrong, it probably isn't a problem if it's a BTEC engineering idea, but if you're doing other engineering tasks where you're expected to demonstrate your ability to do it, just double check your measurements and check that everything is precise. And like I say, here's an error for me, because I'm using a relatively cheap pencil and I'm drawing quite dark so that you guys can see it. That makes that really difficult to rub out without it looking absolutely awful. So take your time. All right, but that's one way of communicating an idea. Now let me just do you a quick sketch. Look, do vanishing point, front corner. If you then plot it off using those same techniques as I've just done with you, you can very quickly communicate the details of that product using perspective. So I'm taking, what, 30 minutes or so? I don't know, I haven't looked at the clock, but it's taken quite a long time. But actually, you could draw that really quickly. If you're talking about how you would improve a design idea, or maybe talking about how you would add an extra piece onto it, you can use your perspective skills, once you've got them, to develop design ideas and then add notes to them and describe and maybe explore different materials. So the process itself is quite long because I'm doing loads of measurement. For you guys, if you're doing it in exam conditions, you might want to do a quicker sketch. Depends on what's appropriate. Okay. Now I'm not going to spend time colouring this one in because that's not the purpose of this drawing. It would be lovely to see that rendered as acrylic. It'd be lovely to see that rendered as metal or brass, aluminium, different types of metals. Or if you can't, just some 3D colouring on that as a possibility. I'm not going to do that within this video though, although I might add that in for a later project. The follow-up from this, I'm going to do an orthographic drawing where we're going to look at the layout of our different views to create a technical drawing, which would be the next thing. And I might then go on and do some isometric with it as well. But this certainly, if you can do that, or you can do your own version of it, or maybe you change the position of your vanishing points and have another go, really good practice for you. Okay, so good luck with that. Have a go. Well done.